Okay. Hello everyone. This is week two, and this week we will learn about some topics on technologies which we are using for conservation of heat and electricity and transport. So, which technology we are using for conservation of heat, and the second one, current status of conventional. What are the conventional energy sources and unconventional energy sources? And then we learn about current state of renewable and renewable energy sources in Pakistan. So basically, technologies that produce electricity, heat, and fuel from biomass feedstock. So the introduction utilizing biomass to meet our energy needs is nothing new and was the primary energy source in early America with the first steam engine using wood to power locomotives, riverboats, ship, and manufacturing facilities. Eventually, coal surpassed wood as the primary energy source in the US in 1895, but wood is still an important energy source for households, industry, and power production today. There are many conversion technologies that use biomass to produce heat, electricity, products, or fuel. This paper will explain the typical technologies used and the research underway to convert a wide variety of biofuel, biomass feedstock into useful form of energy. So biomass is a fuel we can use in the form of some energy like electricity, heat, and fuel. So basically, how what's the treatment of biomass? This is simple thermal conversion. So in a thermal conversion means heat conversion. We have a biomass started combustion. It's combust. We will get the steam, and the steam turbine will generate heat to generate electricity. Okay. Co-firing means using varying percentage of biomass other fuels to produce fuel. Okay. And there's another one, biomass treatment from a conversion. Biomass combined heat and power, CHP. So we have same, but we have to an additional combined heat power, and you will get steam turbine samples and steam heating and cooling that used for the industry or some companies. And we have biomass pyrolysis process, and it's the process in the essence of oxygen just only giving the nitrogen. So in this nitrogen atmosphere, we will get this low temperature and high temperature. Okay. So low temperature primary products you will get biochar and soil and amendment. amendment. That's why amendment is the code of research. And this is primary products biofuel to materials electricity. Okay. So heat and electricity production, thermal, thermochemical, and biochemical conversion. Sorry. So basically, if you are doing about thermal conversion, most of the heat and electricity that is produced from biomass is through a thermal combustion process. Combustion is simply the act of process of burning. Co-firing is another form of combustion and used to describe a facility where biomass combusted in a varying proportion along with coal or other feedstocks such as tire or dried fuel. Facilities that produce only electricity direct and coal-fired combustion are the least efficient, whereas combined heat power facilities (CHP) utilize simultaneous production of heat and electrical energy, thus increasing fuel efficiency. This is that's why we do fuel efficiency and small scale CHP, which is CHP combined heat and power facility. The application that utilize biomass store are typically industrial and manufacturing operations that require significant amount of steam. So pyrolysis, if you're talking about the pyrolysis technology, involves heating organic material or biomass. In the excess of oxygen, the biomass is converted into solid or biochar, a liquid or biofuel, and a gas to a very thermal temperature, and the absence of oxygen at lower temperature. At lower temperature, we can call slow pyrolyzing. Primarily, biochar is produced at high temperatures, while oils are produced for fast pyrolysis. So we are ready and learn slow and fast. Okay? The biochar produced can be used as a soil amendment to increase soil fertility and water retention, or could be used to sequester carbon or produce energy. The bio-oil produced from the phosphorus can be used to fuel an engine generator, thus creating electricity. It is unlikely that this oil will be used as substitute for petroleum liquid fuel because it is unstable, contains char particles, and has half the heating value of traditional petroleum fuel. The pyrolysis of various biomass to restore are currently under research with the many pilot scale facilities working towards commercializing the technology through academic and industrial collaborations. Thermal conversion, in which gasification. So, if you are talking about the gasification, we have to pass the gas CH4 or some like biomass to gas, and the product is gas will can clean up and heat recovery. You will get the same gas, and same gas Fisher drops is like tar, oil, fuel, and chemical. And syngas also used for electricity, and there's gas in heat recovery also for the steam turbine generator. Yeah. And from here you will also buy products like sulfur. Okay. So in thermal conversion, gasification converts solids for a fuel. You can see solid fuel into combustible gas in the presence of steam. Steam, which can be used to create a heat or electricity. This technology is more efficient than direct combustion. Okay, by like 40% or more. When used with advanced turbine design and heat recovery systems, transportation fuels such as diesel and gasoline can be produced using gas technology followed by future growth. So in the biochemical conversion, we have a biomass digester, this is anaerobic digestion and aerobic digestion. We look at the biogas used for generators and biogas also for generators like the heating. Okay, and we have upgraded to biomethane gas and methane transferred to biofuel. So move on the biochemical conversion, the whole discussion about the biochemical conversion, which we will get a few. Anaerobic digestion is used to describe the process of microorganisms breaking down biomass to release energy biogas, how to manage waste from landfills or animal operations. Biogas is composed of methane, carbon dioxide, and other trace gases. The gas can be used directly as fuel or used in gas turbine, gas engine to produce electricity, or may be upgraded to higher quality fuel called biomethane, which is chemically identical to natural gas. Most biogas resources are biofuels used for transportation are blended into the traditional petroleum. Like fuel, such as gasoline and diesel. The primary crops that are used to produce biofuels are usually classified as sugar, starch, or oil seeds feedstock. Advanced biofuel feedstock under research consists of fast-growing trees and short rotation woody crops and perennial grasses such as switchgrass that are grown especially for the production of fuel. There are many technologies available to produce a variety of fuels, but this paper will address the most valuable technology for producing gasoline and diesel fuels from biomass feedstock. These include fermentation and transesterification and gasification combined with Fischer-Tropsch. So we have a biochemical conversion process and technology. Biochemical process are process use chemical enzymes and microorganisms to break down feedstock into compounds. First generation biofuel such as corn or sugarcane have readily available sugar which can be fermented to produce biofuel. Okay, so advanced biofuel feedstocks such as fast-growing trees and switchgrass are fabulous or cellulose and will need to further broken down to isolate cellulose from the other plant fibers. Ethanol is the most widely used biofuel and is a fuel additive for petroleum gasoline. the majority of which is produced using fermentation. Biodiesel can be produced in a process known as transesterification. The physical properties of biodiesel can be varied depending on which feedstock is used, and this is probably due to the fatty composition of feedstock. Standards are in place to ensure that customers are refueling their vehicles and equipment with a quality biodiesel blend. So in overall, you can see this is the thermochemical conversion. A thermochemical conversion, heat conversion, uses heat and chemical to break down a variety of biomass feedstock into a syngas or gas mixture that contains varying amount of carbon monoxide and hydrogen. A catalyst is used to accelerate the chemical reaction of syngas into liquid fuel. The type of catalyst used determines whether the fuel will be an alcohol or hydrocarbon product. Diesel is the most commonly produced fuel using a thermochemical conversion process. The gasification technology, along with the Fischer-Tropsch synthesis, can produce renewable diesel from many different carbon-containing feedstocks such as coal, natural gas, and biomass. When biomass is placed in a gasifier and partially oxidized or combined with oxygen, as a gas is produced. The next step in the process recovers the heat from the syngas and sends it through a filter to remove the impurities. Fischer-Tropsch synthesis creates a chemical reaction that produces hydrocarbon or a petroleum-based substance from the syngas. The hydrocarbons are then refined to produce diesel, gasoline, kerosene, liquid petroleum gas, methane, ethane, light and heavy weights, and power. The renewable diesel produced is a cleaner fuel and is more compatible with existing infrastructure and transportation. So you can see a combined heat and power operation using biomass feedstock at the Purdue rendering plant and see photographic quality of electricity work. The technology that produces biofuel, the fermentation process that creates a chemical change in sugar. Like suppose sugar cane or starchy from plants by the action of bacteria that convert sugar into ethanol and carbon dioxide. The mash then undergoes a distillation process in which the ethanol is removed from water. Cellulosic biomass, glass, bone, stove, or wood must undergo a process to convert cellulose to sugar first. Afterwards, the sugar to ethanol process can then be used to produce cellulosic ethanol. And then the method transesterification. Biodiesel can be produced from animal fats or plant oil. Through transesterification, by mixing an alcohol, methanol, or ethanol in the presence of catalyst, alkali acids, or ethylene. There are several steps involved in transesterification, and the process is essentially lower viscosity and oxygen content of the oil producing biodiesel and glycerol byproduct used in source. So, Fischer-Tropsch synthesis, this process utilizes syngas produced from gasifying biomass after impurities have been removed. Fischer-Tropsch synthesis produce hydrocarbons which are then refined to produce a wide variety of fuels and chemicals. Fuels produced include diesel, gasoline, kerosene, liquid petroleum gas, methane, and ethane. So overall, the conclusion of transport and electricity technologies available for production of heat electricity include combustion gasification, pyrolysis, and anaerobic digestion for biofuel production. The technology available include biochemical and thermochemical conversion process to break down the biomass feedstock into profitable fuel. Research and innovation for biomass conversion technology is still underway as the industry moves toward building commercial scale facilities that will use advanced bioenergy products. Increasing bioenergy market share is not only difficult in a mature fossil fuel energy sector, but also challenging when competing against highly volatile market prices. Investing in the research and innovation for a few new technologies that will provide the renewable energy industry a competitive advantage against the fossil fuel sector is currently underway as society continues to demand cleaner renewable sources of energy. There has already been significant progress in the increase of renewable and, in particular, biomass use worldwide. The use of biomass for electricity, heat, and transportation fuel will continue to meet energy needs with sufficient product support, technological innovations, and continuing research. So, following on the reference of this about transportation technologies for biomass fuel for electricity and so ओके इसके साथ साथ हमने देखा कि ये टेक्नोलॉजीज जो यूज हो रही हैं फॉर बायोमास कन्वर्टिंग electricity for heat purpose or for fuel purpose. So there the video is watch this video which will help you about converting biomass and in animation. So please watch.
With the depletion of fossil fuels and growing concern over climate change, the search for renewable energy sources has intensified. Today, one company, Invergent Technologies, offers a practical and proven path to green energy. It's called RTP. This rapid thermal processing technology converts biomass such as forest or agricultural residuals into RTP green fuel, a light, pourable liquid that can be used for heating and power generation. Soon it will also be refined into transportation fuels such as green gasoline, green diesel, and green jet fuel. To bring the benefits of RTP to a broader marketplace, two recognized leaders in energy, UOP, the Honeywell company, and Ensign, formed Invergent Technologies in 2008. This joint venture combines the nearly 100 years of petroleum, gas, and petrochemical expertise of UOP with Ensign's proprietary RTP technology. This enables Invergent Technologies to offer the technology and equipment to provide the fastest and lowest risk path to a renewable liquid fuel. RTP Green Fuel. It starts with Ensign's proprietary RTP technology. RTP is the world's only fast pyrolysis process with proven commercial application. In fact, it's been used for over 20 years in the manufacture of more than 30 different products, including everything from flavorings to adhesives. Here's how the process works. RTP uses non-food cellulosic biomass feedstock, typically from the forest products and agricultural sectors. This feedstock is rapidly heated in the absence of oxygen by a tornado of hot sand. The biomass is vaporized, then cooled, yielding RTP green fuel, all in less than 2 seconds. RTP also yields char and gases which are returned to the unit and used for heat generation, making the process virtually self-sustaining. RTP green fuel can be used immediately on site, stored for later use, or transported for use at a different location. The option for storage or transportation is a significant advantage over direct combustion and gasification technologies. The fuel is very flexible and can be adapted for use in turbines and slow-speed diesel engines for the generation of electricity, or for heat generation in heavy industries such as pulp and paper, or other energy-intensive manufacturing businesses. And because it contains little sulfur or nitrogen and is virtually carbon neutral, RTP green fuel is an ideal option for any company that wants to reduce its carbon footprint. The compact modular construction takes up relatively little space, yet the technology is very scalable. Processing capacities range from 100 bone-dry metric tons of biomass per day, like this facility in Renfrew, Ontario, Canada, up to 1,000 metric tons per day. RTP also accommodates a wide variety of feedstocks, forestry and agricultural residuals, wood-based construction and demolition materials, and sustainable energy crops such as miscanthus or switchgrass. RTP is a proven, practical technology that's available today to help companies significantly reduce greenhouse gas emissions. But its future looks even brighter. RTP from Invergent Technologies. Proven technology from a trusted partner. The keys to successfully converting low-value biomass to a high-value liquid asset today.
Okay, जिस तरह से आपने देखा इस वीडियो में बायोमास की टेक्नोलॉजीज से बायोमास से आप रिन्यूएबल फ्यूल्स एंड ऑयल एंड गैसेस को निकालते हैं विद डिफरेंट टेक्नोलॉजीज। ओके, इसके साथ साथ हमने देख रहे हैं कि एडवांस थर्मल कन्वर्जन ऑफ म्युनिसिपल सॉलिड वेस्ट, तो वेस्ट भी है उसको एडवांस थर्मल कन्वर्जन से ये कन्वर्जन टेक्नोलॉजी विल गेट सम फ्यूल एंड गैसेस, सम ऑयल।
Clean industries entered the waste-to-energy sector over a decade ago, applying commercially proven Japanese thermal treatment technologies for the processing of municipal solid waste, or MSW. Converting waste into energy is a key component of any efficient waste management system, which plays a significant role in the circular economy. By using these advanced thermal treatment technologies, MSW that cannot be recycled is converted into environmentally friendly energy. To begin the continuous process, trucks of municipal solid waste and delivered ash from a local incinerator pulls up to the 1,500 ton a day facility. The solid waste trucks are weighed and then dumped into the waste pit. The delivered ash trucks are emptied into the ash storage silo. The crane lifts the waste into the hopper. From the hopper, the waste is shredded. The shredded waste is dosed with the delivered ash and fed directly into the fluidized bed gasifier. The dosed waste is heated between 550 and 600 degrees Celsius in a controlled, low-oxygen environment. Syngas, ferrous, and aluminum metal are extracted during the gasification process. The recovered unoxidized metals can be easily recovered and recycled. The syngas is then sent into the ash melter, where it is heated to over 1,300 degrees Celsius. A molten slag is produced from the superheated fly ash. The vitreous slag is cooled in the water quench and pulverized into a fine powder, which can be used in construction materials as an aggregate substitute. The flue gas then enters the waste heat recovery boiler, which converts the thermal energy into steam and hot water. That steam is then sent into the turbine generator, where it produces over 36 megawatts of power, and the hot water can be used for district heating and cooling. The flue gas then enters the electrostatic precipitator or bag filter. The dust collected can be recycled into construction materials such as concrete products. The dust-free gas passes through the wet scrubber, where the hydrogen chloride and the sulfur oxides are removed. After wet scrubbing, the gas enters the selected catalytic converter, removing the nitrogen oxides. And before the treated flue gas is vented up the stack, it passes through a constantly monitored flue gas analyzer. A municipal waste-to-energy facility of this size can process the waste of 1.5 million people. Although advanced thermal processing of solid waste does produce some emissions, it produces the equivalent air pollution of less than 6 passenger vehicles. And those emissions fall far below air regulation standards. Some major advantages of Clean's advanced thermal treatment of waste are reducing the volume of waste and preserving landfill space. Municipal waste-to-energy facilities reduce the environmental impact of transporting waste over great distances. It allows for the recovery of clean energy from the waste stream, as well as the recovery of resources that can be recycled. To learn more about our municipal solid waste solutions, please visit cleanindustries.com.
Okay, in this video, I think आपने बहुत अच्छी तरीके से एक पावर प्लांट देखा कि म्युनिसिपल सॉलिड वेस्ट पे तो वो वर्किंग कर रहा है एडवांस थर्मल कन्वर्जन पे, इसकी वर्किंग थी तो आप देख सकते हो कि किस तरीके से इसमें प्रोसेस था और किस तरीके से हम इलेक्ट्रिसिटी जनरेट कर सकते हैं. Okay, continue. As we already know about the conventional and unconventional sources of energy in Pakistan, the conventional sources like coal, petroleum, natural gas, or non-renewable sources of energy. There is a difference between non-conventional and conventional. We already done this slide in next week one. Okay, so this is you can see the basic difference between they have been used in use since a long time. For example, firewood and coal have been used since a long time. These resources have recently developed and are still developing. For example, the technology of producing electricity from solar panels and they are commonly and widely used sources for thermal power with conventional sources, and they are compared new sources to use solar panels. So move on. And according to Pakistan situation, we have conventional and unconventional, or we can say renewable and non-renewable status. of 2019 generation. The electricity generation, you can see this is an electricity generation, sources from furnace oil, and fossil fuel gas and coal, with the sources of hydroelectric, big sources that like natural, nuclear, others. So we get this energy situation. So energy resources, if you are talking about the wind potential, solar potential, coal resources, and oil resources, this all in the worldwide range. This you can see this is the resources and the units of producing energy. So first of all, we are deeply into fossil fuel coal. We have Pakistan coal. Coal reserve was in 10, you can see the data, and 17 in the world, Pakistan coal production, we have a small production, and 24 in the world. And coal consumption, we have consumed this year according to yearly defect and coal imports and export. Okay, we are importing and export. Net imports like this data we have shown to the latest year with complete data in all categories. So Pakistan coal reserves in Pakistan. So Pakistan hold these tons and of propane coal reserves total ranking 2012, same data when written, accounting for 0% of world total coal reserves of million tons. Okay. Pakistan has propane reserve equivalent to 33 or 331 times its annual consumption. This means it has about 331 years of coal left. So we have reserves controlled and 31 years coal left in Pakistan. We can see, finish. Okay, the history of coal reserve in Pakistan history, you can see usage, including coal reserves. And coal consumption in Pakistan. Pakistan consumes lead, and Pakistan consumes overall per capita. Okay, and coal production, Pakistan is to produce tons of coal per area. So coal imports like this and history of coal consumption and production. This is the Pakistan coal consumption and production. So you can see the consumption and production also increasing, coal consumption and production day by day. So yearly, you can see the yearly coal production means what consumption plus net export their share of the total proven reserve. The proven reserves, we have a proven reserve 99% production and consumption is we are using only 0.3%. So where is the largest coal reserves in Pakistan? The Pakistan largest coal reserves are found in Sindh, measuring approximately 17 billion tons. The Parker division of Sindh is said to be close to 2%. And let's talk about the coal. What is there? We can find coal average, coal farms, coal reserves are available in almost every country worldwide. With the reserves in around 70 countries. The biggest reserves are in USA, Russia, China, Australia, biggest reserves. Okay. So here the data about the biggest reserves. So there are an estimated 1.1 trillion tons of proven coal reserves worldwide. This means that there is enough coal to last us around 150 years at current rates of production. In contrast, proven oil and gas reserves are equivalent to around 52 years at current production level. After centuries of mineral exploration, the local location, size, and characteristics of most countries' coal resources are quite well known. What tends to vary much more than the assessed level of resources. Such that the potentially accessible coal in the ground is a level classified as proved recoverable reserves. So here in summary, where is coal found reserves made, coal exploration further reading. So resource, what is resource? The amount of coal that may be present in the deposit or coal field. This does not take into account the feasibility of mining the coal. Not all resources are recoverable using current technology. And then we have a reserves. The reserves can be defined in terms of proved or measured reserves and probable or indicated reserves. Probable results have been estimated with lower degree of confidence than proved reserves. And their proved reserves that are not only considered to be recoverable but can also be recovered economically. This means they take into account what current mining technology can achieve and the economics of recovery. Proved reserves will therefore change according to the price of the coal. If the price of the coal is low, proved reserves will decrease. Okay. So proved reserves. So reserves means location of the world main fossil reserves in America. You will find in America reserves and the Europe, and move on to South and Central America, Africa, Middle East, India, China. This is all in the coal, oil, and natural gas. Fossil fuel. Okay. So, coal exploration, if you are talking about coal exploration, coal reserves are discovered through exploration activities. And the process usually involves creating a geological map of the area, then carrying out of geochemical and geophysical survey, followed by exploration drilling. This allows an accurate picture of the area to be developed. The area will only ever become a mine if it is large enough and of sufficient quality that the coal can be economically recovered. Once this has been confirmed, mining operations begin. So coal reserves can be extended further through a number of developments, including the recovery of new reserves through ongoing and improved exploration activities, advance in mining techniques, which will allow previously inaccessible reserves to be reached. Peak coal falls in the coal reserve to production R/P ratio. Over recent areas have prompted questions over whether we have reached peak coal. Peak coal is the point in time at which the maximum global coal production rate is reached, after which the rate of production will enter irreversible decline. However, falls in the reverse to production ratio can be attributed to the lack of the incentives to pull up reserves, rather than a lack of coal resources. Exploration activity is typically carried out by mining companies with short planning horizons rather than state-funded geological survey. There is no economic need for companies to prove long-term reserves. All fossil fuel will eventually run out, and it is essential that we use them as efficiently as possible. So here we have a Pakistan natural gas resources and summary. Okay, in Pakistan natural gas summary, gas reserves, we have million cubic feet unit, and gas production, gas consumption. So production and consumption, you can see yearly surplus, gas import and export. So data is, like 2015. In natural gas industry about the Pakistan, natural gas production is at a relatively high level, and remaining reserves are estimated to be about 85 billion cubic meters. Generally, for Pakistan gas field are only expected to last for about another 20 years at the most due to heavy industrial usage. The Sui gas field is the biggest natural gas field in Pakistan. It is located near Sui in Balochistan. The gas field was discovered in late 1952, and the commercial exploitation session of the field began in 1955. Sui gas field accounts for 6% of Pakistan gas production. Remaining reserves are estimated to be about 8 billion cubic feet, and daily production is about 15 million cubic feet of natural. The operator of the field is Pakistan Petroleum Limited. Okay. This is the history about the natural gas industry of Pakistan. And the gas reserves in Pakistan, we have reserves and 29 in the world according. And Pakistan we have reserves like Pakistan gas reserves in cubic feet, and 12 years of natural gas left we have remaining. History in Pakistan, you can see this is working all around the gas coming down reserves. Okay. And move on to gas consumptions and production. We have same consumption and production. We have data and gas imports that are in history of gas consumption production. So yearly we have a consumption 8.3 and proven reserves we 19 1.7 billion, like data about gas in Pakistan. So overall, the leading countries by proved reserves of natural gas from 2018 in trillion cubic meter, Russia, you can see Russia is, in 2019, we have gas field more and more. For Iran, Qatar, will find more gas, natural gas is over. How about oil, Pakistan oil situation? If you're talking about Pakistan oil situation, the oil reserves and oil production, oil consumption, we have data about 52 production and consumption, you can see. So we have oil, 2 years of oil left if you are working consume reserves. Okay. So history of oil reserve Pakistan is moving up, and so here is the consumption and oil production data. You can see we are consuming more barrels per day, and production is very short. So history of oil consumption and production is moving day by day increasing, and we have a consumption improving less, very few. Okay. The short petroleum industry in Pakistan, according to United States Energy Information and Administration (EIA), Pakistan may have over 9 billion barrels, which is cubic meter, of petroleum oil and 105 trillion cubic feet in natural gas, including shale gas reserves. Okay, short. As per BPA statistical review of world energy, at the end of 2020, Pakistan had the following proved reserve fuel: 0.5 trillion cubic feet natural gas and 2 liters of coal, 70 something like that. Okay. History show. Oil discovery, recovery, how it is recovery and history. Pakistan first gas field was found in the late 15th Rajasthan near Jamsu gas field. The Tot oil field was not discovered until the early 1960s in the Punjab, the most rich resource in Harpo Company job. It covers square kilometer. Pakistan Petroleum and Pakistan oil field explored and began drilling these fields with so it had 1961. Activity began into during 1964. Okay. And the Tool area is one of the oldest oil producing regions in Pakistan, with the first oil well drilled in 1964 when President Ayub Khan encouraged mineral development policy. It is located in Kothar, Plateau, Punjab province, which is located approximately 1 kilometers southwest of the capital of Islamabad. In 1964, the first well was drilled and commercial production started in 1964-67. There are about 60 million barrels of oil in place, of which 1250 is recorded. At its peak during 1986, the field was producing approximately 2,400 barrels of oil per day, which has grown steadily since then, producing both oil and 2 layers of degree of natural gas. Oil production was entirely confined to the Potawatomi Plateau till 1989. Union Texas, Pakistan discovered its first oil field in the lower Sindh. By 1998 to 1999, the lower Sindh gas field were producing more oil than the Potawatomi Plateau. Since then, new deposits have also been found here. This is all about oil. So here we are talking about the natural gas and oil data and the current status. The search for oil in Pakistan started in 1868 when the first test hole was drilled at Kunda near Miawali and continues to the present day. In Pakistan, large areas are covered by sedimentary rocks which have petroglyph members. The search is for stratigraphic and structured traps where oil could accumulate. Such favorable structures are usually not found in areas of intensive folding such as the Northern Mountains. The possibilities of major discovery either in onshore or offshore area is considered quite bright. Parts of Pakistan adjacent to the oil and gas producing field of Iran have a similar geological history. At the same time, in independence 1947, Pakistan inherited 4 producing fields: Kharpur, Khwar, Bulan, Johar and Balkasar. Since that time, 4 more fields have been discovered: Tarsal, Tot, Sarang and Mayal. All of these lie in Potawatomi Plateau. Traces of oil occur at several other localities, and exploration continues in Punjab, Sindh and Balochistan by arrangement between various foreign companies and the Oil and Gas Development Corporation. Far Oil Field lies 54 miles southwest of Rawalpindi in Camberwell, now Atop district. This is the oldest field in Pakistan discovered by the Atop Oil Company in 1915. Production commenced in 1922. Fort Dome is formed of upper murray beds of grey sandstone and red shale. This field is now almost exhausted. Dunan oil field is located 10 miles northwest of Oil, discovered in 1973. This is the biggest field in the country and also produces substantial quantity of gas. The structure is a gentle dome, about 36 square miles in the area, and oil is about from the landing and raincoat horizon of the vessel Murray bed. Joamir oil field was discovered in 1944 by the Atop Oil Company. The structure is narrow and declining, and the oil producing horizon Savisar limestone. The oil is heavy alphatic oil and is transferred to the Morbo refinery by railway. Balkasar oil field is located west of the Johor, Joya-Mir and Jhelum district. The first well was used by Atop Oil Refinery in 1945. The structure of the field is gentle and slanted with then both have eosine limestone. The oil is alphatic, suitable for furnace fuel. Castle oil field was the first field discovered after independence. It lies a few miles northwest Balkasar, to which it is joined by backland. The Castle is explored on the surface, and the oil occurs in limestone. Quality is similar to that of Balkasar oil. Tut oil field was discovered in 1968, and the Port Sarang and Mile field even more recently. All are located in the Camberwell, now Atop district, and have recently begun commercial production. Production of crude oil in 1970 stood at 2.9 million barrels, but this way only 20% of the country requirement. Large quantities of crude oil are imported each year, basically for transport and are a heavy drain on the country foreign exchange. Imported crude oil is refined at Karachi near Karachi and local crude oil at Morbo refinery. Karachi also produces a range of petrochemical products, and two refineries fulfill more than two-thirds of the requirement of oil products. So overall, this oil and natural gas. Natural gas is the cheapest and most efficient source of energy in Pakistan. The country is well endowed with natural gas, totally estimated reserve being 15.85 million cubic feet. 10 gas fields, of which only 4 are in production, have been discovered to date. The first field was discovered at Sri in 1952 while drilling for oil. As a result of an intensive program of test drilling, additional fields were found at Sindh, Punch, Kharagpur, Kanpur, Mari, and Madarni, Sari, Siri, and Jacobran and Julian. The natural gas of Pakistan has high methane content, usually 70-90%. Production has increased rapidly from 25,750 million cubic feet in 1959-60 to 127,075 million cubic feet in 1971. Sri is the major producing field. It lies in the Sibi district of Pakistan at the foothills of the Murray range and is one of the biggest fields in the world. The reserve covers an area of 75 square miles. Production from Dulan is associated with the oil field and is conveyed to Rawalpindi by a 65 miles pipeline for power generation and domestic and industrial use. This gas also reaches where it is used in cement or in natural gas is used for power generation and by industry. Power stations using natural gas have been built at Karachi, Hyderabad, Jamshedpur, Multan and Faisalabad, and 37.5% of total production is consumed in power generation. Fertilizer factories uses 93%, cement factories 41%, 14%, and other industries including textile, 26. Natural gas is playing a vital role in the economic development of Pakistan by providing cheap fuel for industry. Commercial and domestic consumption 3% is still very limited. It's all about about the gas, oil, gas of Pakistan resources. Okay, Pakistan. Now we have to come for the point about nuclear, energy and the uranium reservoirs. So nowadays we know, as we know, Pakistan has more than 1,000 uranium reserves. Introduction, we had this paragraph I took the research work. Uranium is a radioactive with a silvery colored trace element having a great importance for nuclear reactor and weapons. Its overall concentration in rocks is about 1 to 6 parts per million. Total production of uranium in the world is about 5,902,900 tons unit per year, but Pakistan produces less than 1% of this annual production. As in Pakistan, uranium research is very restricted for safety of nuclear power, so very less data is available to study uranium deposits in Pakistan. During last 70 years, the Pakistan Atomic Energy Commission PAEC identified domestic uranium by exploration program nationwide, but unfortunately no authentic reports are available on this field to keep continuing further research. Although a number of radioactive sites have identified igneous rock, pygmatites, and such plus uranium deposits are sandstone type deposits or sedimentary rocks. Sandstone type uranium deposits fulfill 30% of total world uranium requirement. So the study of such type of deposits is very important. So in this table, you will see about the uranium deposit of Pakistan, uranium Bengal have a data in here. You can see overall the locality and the year. Find they they found this uranium deposit in Delhi here. And occurrence uranium mineral the percentage on grade for grade is the occurrence. Okay, move on. In this list of countries by uranium production, this contains list of countries by uranium production. The first list is compiled by the World Nuclear Association and measure uranium production by Jones Mine. The second list is compiled by Trade Tech, a consulting company which specializes in the nuclear fuel market. In the list of countries, you can see the World Nuclear Association (WNA), and this is a country and uranium production 2008 and percentage of world production. Okay. The world production is 100%, and if you are going to Pakistan, 45 uranium production. Okay, data is here. Okay, let's talk about renewable energy sources. Sorry. So Pakistan aims this article we already learned week one, but about the big two renewable energy sources regarding Pakistan. Pakistan is achieving 5 to 6 of its total on electricity supply from renewable sources, like including hydropower by 2030. Total installed power capacity stood at 26 gigawatt a year and the end of 2016, of which 4% was renewable energy. Okay. So renewable energy, we are talking about the Pakistan. So we have in Pakistan megawatt of installed solar photovoltaic biomass, and this government of Pakistan also agreed about for wind power project regulatory they are making. So northern we have revised strict for solar projects and wind energy about wind. So wind normally in the coastal Balochistan areas and the wind speed is on average, and some sites are for the getting under to go okay. So particularly in southern regions of Sindh and Balochistan, the technical potential of wind power is high along the 1,000 kilometer coastline where wind will range 5 to 7 million minutes per second. The potential capacity of wind energy is estimated about 1 to 2 gigawatt per year, more than double of the country's power generation level. A new completed wind farm in Garo, Sindh province is one of series under construction in Pakistan to reduce the country's serious energy defect. So we have also solar. The solar potential is estimated to be over like 100,000 megawatt. Pakistan has the highest solar potential irradiation across the country, is around 4.5 to 7.5 kilowatts per meter square per day. So the highest solar potential. So here we have in Pakistan, you can see this so solar village electrification. More than 40,000 villages which are so far from the grid that it becomes costly and uneconomical to extend the grid to these locations are prime candidates for village electrification using solar home systems. Solar water heaters and geothermal heat pumps. This is a big market for investors also. SWH solar water heater and the GHP geothermal heat pumps in domestic industrial sectors. Only 22% of the population has access to piped natural gas. And the productive use in agriculture, solar power efficient pumps could replace the 268,000 water pump tube wells with a sand section load of over 2,500 megawatt, 2,550 megawatt operated with electricity and other 850,000 diesel water pumps that consume 72,000 total oil diesel annually. And the street light, if you are Pakistan, is over 500,000 street light with a load of over 400 megawatt. Most of these street lights are based on 80 megawatt, 80 watt, 125 megawatt, and reduced sodium lights. They offer opportunity to be replaced with efficient solar light. And if we are talking about the biomass, we have also in Pakistan renewable and out of all total area 79 million hectares. 212 and 2.2 million hectares are cultivated. Almost 80% of cultivated area is irrigated. The country has the world's largest continuous irrigation system. Forest cover 4 billion hectares, 5% of Pakistan's total area. And according to FAO, this number has dropped continuously since 1940. Biomass availability in Pakistan is also widespread, approximately 50 tons, 550,000 tons of solid waste, 225,000 tons of crop residue, and over 1 million tons of animal manure are produced daily. It is estimated that potential production of biogas from livestock residue is 8.8 to 17.2 million liters of gas per year equivalent. Larger sugar industry in Pakistan also generates electricity from biogas energy for utilization in sugar mills. Annually, electricity production from biogas is estimated about Pakistan's current power generation level. In the present electricity crisis, recently government allowed sugar mills to supply their surplus power up to limit 700 megawatt to the national grid. It is estimated that the sugarcane biogas can potentially be used to generate 2,000 megawatt of electric power. However, presently it is difficult to obtain more electricity from sugar mills due to limitation because most of sugar mills are located in the remote rural areas, which are not often connected to national grid. Integration of electricity generated from biomass energy to national grid can ease electricity shortage in the country. A large number of people in rural areas in Pakistan depends on forest for their livelihood, fuel wood, and shelter. Many use the forest in unsustainable way to satisfy their domestic energy needs. Therefore, forest depletion and degradation are a major challenge. Almost all of Pakistan biomass Power generation is done in steam power plants. In biomass gasification, newest formation technology has not been introduced in the country. The sugar industry has the highest utilization of biomass, with every singly sugar mill being equipped with a biomass boiler for the production of electricity. Some even incorporate high pressure boiler to increase efficiency. The framework for power cogeneration for biogas and biomass-based sugar industry project introduced in 2013 is expected to attract 50,000 megawatt to 2,000 megawatt in the generation in the short term between 2006 to 2018. So that's all about the biomass. Here we have another renewable energy source in Pakistan, hydropower. Large hydropower has proved to be the cheapest source of electricity despite the high availability of hydropower resources. Low investment in this sector hamper the utilization of this potential source. Smaller, less than 50 megawatt sites are available throughout the country. The micro hydropower sector has been relatively well established yet. Since mid-18th century, micro hydropower plants supply electricity to some 40,000 rural families. Most of the plants are community-based and situated in the northern areas and Chitral. Small hydropower is considered as another promising option for off-grid generation of electricity. Provincial government mainly handled the small hydropower sector in 2014. 128 megawatt has been operational in country. 877 megawatt is under installation, and around 1500 megawatt is available for the further development. The potential for micro hydro up to 100 kilowatt is estimated at 350 megawatt in Punjab and 300 megawatt in northern Pakistan. So we have a renewable energy in Pakistan. Renewable energy in Pakistan is a relatively underdeveloped sector. However, recently there has been some interest by environmentalist groups and from the authorities to explore renewable energy sources for energy production. In light, most of Pakistan renewable energies come from hydroelectricity. Okay, so we have a solar energy. We already know about the solar. There have been some efforts to install solar power in Pakistan and expand the use of solar energy in Pakistan. The average amount of daily sunlight in Pakistan is 8.5 hours. There are a few cloudy days even in the wettest region. 8 power generation plants have been installed and 11 are in various stages of completion. Solar, 50 megawatt of solar, 8 cloud is working. Okay. Further, feasibility studies are undergoing. In December 1980, the first solar photovoltaic system was commissioned, located in Mominila village 60 kilometers from Islamabad. 4 solar systems have been commissioned in Pokhara, Laspela district, Hakhara district, and Marmari district. Now that system is unserviceable and Nital Khan, Lagari, and Digri Mirpur district, the Punjab government announced the establishment of Qaid-e-Azam solar park over an area of 5,000 acres in the Cholistan Development Authority in Bahawalpur. A practical example of the use of solar energy can be seen in some rural villages of Pakistan where houses have been provided with solar panels, different electric fan, and energy-saving bulbs. One notable and successfully implemented case was the village of Naren Koren, about 50 kilometers from Islamabad, which employs the use of 100 solar panels installed by local firm. Free of cost, these panels have provided energy through lights and fan facilities to some 100 households. The alternative energy development brought installed 200 solar home systems at district Gujarat, Balochistan, in a remote off-grid village, Khara. Government of Balochistan launched a program to electrify off-grid villages of various districts through a solar technology. So we have a wind power, wind also main article in a wind power in Pakistan. Pakistan is developing a wind power plant in Jimpur, Jampir and Garo, Kheti Bandar and wind Qasim in Sindh. The government of Pakistan decided to develop wind power of energy sources due to the problem supplying energy to the southern coastal regions of Sindh and Balochistan. The project was undertaken with assistance from the government of China. Another area with potential in Sawat, which shows good wind condition and wind power investment. The Changai district in Balochistan has good potential for wind power in the Nukandi area near the Afghan area border, with wind speed often more than 12% higher than average return of energy generation. So here we have a windmills at Garo, you can see. Okay. Some examples are Champi wind power plant operational and Garo wind power plant operational. Qasim wind power plant under construction. Also, we have a tidal power. Tidal power has not yet been operational in Pakistan compared to other renewable energy technologies, but in near future, it may play a key role. Something that tidal power plant in coastal peaks of Pakistan can solve the energy crisis found on of the some of the level. The coastal line of Pakistan, which is about more than 1,000 kilometers long with dominant features, is the best source of harnessing tidal energy. Instead, two sites creek systems of Indus Delta, 170 kilometer and 2 to 5 meter tidal height at the Korangi Creek are available to exploit the tidal energy. Solmina Beach and Kalamat are also good prospects of tidal energy in Balochistan. Government has issued license to provide private companies to take measure to build tidal power station in February. Since then, the engineering work is under process and initially a 10 megawatt plant is proposed as Sunminai, by construction was expected to start by the end of 2030. Okay. So we already know about the renewable energy and fossil fuel of Pakistan. So Pakistan net metering policy for solar, photovoltaic and wind projects, September for project. Solar PV and wind generator under 1 megawatt of capacity are allowed to sell back produced electricity to the national grid. The payment of the purchased electricity from distributed solar and wind generation units shall be the same as of the off-peak electricity rate charged by utility capacity companies for electricity sold to distribute solar and wind generation units. The residential and commercial industrial scale owners of the eligible generator can participate in the scheme. As of the today, November 2019, more than 2,000 licenses on net metering issued with total capacity. Power generation policy. This policy addressing the hydropower projects and the thermal power projects. Under this policy, government of Pakistan encourages public-private partnerships in scope of this policy. The incentives are concessions available to provide private power projects will also available to projects implemented under PPE mode in the accordance with the applicable law. The main objective of this policy are to provide sufficient power generation capacity at least cost to encourage and ensure exploitation of the indigenous resources, to ensure that all stakeholders are looked after in the process, a win-win situation, and to be attuned to safeguarding the environment. This is Pakistan's situation. So nowadays, National Power Policies 2013, central part of the government plans to support the current and future energy needs of the country with the three focus points: efficiency, competition, and sustainability. It outlines incentives to attract more private incentive investment and infrastructure development and schemes that will allow public-private partnership. Further attempts to diversify the energy mix and the role of renewable energy is gaining significance in achieving sustainable energy and energy security. Among 9 other major aspects, it gives the directive to ensure the generation of inexpensive and affordable electricity for domestic, commercial, and industrial use by using indigenous resources, and to align the ministries involved in the energy sectors and improve the governance, all related federal and provincial departments as well as regulators. National policy we have Pakistan 2025, One Nation, One Vision 2013. We have 6 sets of 25 goals in accordance to 7 pilots. Among them, pillars are 6 energy, water, and food security with the following goals concerning energy. Energy, double power production generation to over 45,000 megawatt to provide uninterrupted and affordable electricity, and increase electricity access from 57 to over 90% of the population. Energy reduce average cost per unit by over 25% by improving generation mix 15% and reducing distribution losses 10%. Increase percentage of indigenous source of power generation to over 50% and addressing demand management by increasing usage of energy efficient appliances product to 80%. The elimination of current energy demand supply gap by 2018 and optimizing the energy mix of oil, gas, hydro, nuclear, solar, wind, and biomass are some of the key priorities of the policies. So we have these policies regarding, and we have alternatives. Okay, जिस तरीके से आपने देखा कि पाकिस्तान के फॉसिल फ्यूल एंड रिन्यूएबल एनर्जी रिसोर्सेज के तरीके से पाकिस्तान के रिजर्व्स हैं प्रोडक्शन फॉर कोल, गैस and oil fields. So have a look, watch this video for energy resources for equally.
So we'll show you the details of your presentation project on energy resources. You will be working with a partner and will research and make a video about one type of energy resource using Powtoon. I'm sure you know that there are many different types of energy resources. First type is called chemical or fuel energy that is commonly used in power plants and is also used to run our cars and even cook our food. Second is solar energy, whose light energy is captured in solar cells to produce electricity directly. Third is known as nuclear energy, that is produced by splitting atoms inside nuclear reactors in power plants. Fourth type is called wind energy, that is captured not just by one, but many windmills to produce electricity. Fifth type is from the kinetic energy of moving waves and may also be from the rising and falling of water called tides. Hydroelectric energy is the sixth type that changes the energy of falling water into electricity. Lastly is geothermal energy, which is heat energy from the earth. Now you ask, what will each group be talking about? Here are the 5 important questions you need to answer. Number 1, where is this resource coming from? The sun, wind in the air, sea, or inside the earth? Number 2, how is electricity produced from this type of energy resource? Your video must be able to explain in simple details from the source to the next step, then to the next, until it finally becomes electricity that may be used in homes and in industries. Number 3, which countries use this type of energy resource? You may name as many countries as you can that are truly using this type of energy resource. Number 4. What are the advantages of using this type of energy resource? Is it cheap? Is it renewable? Does it produce a huge amount of electricity? These are examples of advantages. Number 5. What are the disadvantages of using this type of energy resource? Maybe it is expensive, or harmful to the environment, or non-renewable. Give at least 3 of both advantages and disadvantages. Do not forget to include clear images or photos onto your presentation, and make sure that you take turns with your partner in speaking on the video. So there, your teacher will hand you the rubric in grading both the content and the finished video. Do you have any questions? Please feel free to ask for help. Good luck!
Okay, in this video you have learned basically the energy sources of, basically how renewable energy is described and fossil fuels is described. So I would like to continue this introduction to energy sources for your entertainment, for physics. Please watch this video for getting more knowledge.
Throughout most of human history, humans' primary source of energy was wood, which we burned to keep us warm and cook our food. However, over the past 200 years or so, this has changed dramatically. Although many people in developing countries still rely on wood as their primary form of energy, the rest of the world consumes huge amounts of non-renewable energy resources, like coal, oil, and natural gas, which we refer to as fossil fuels, and nuclear energy. In the past 50 years, though, there has also been a massive rise in the use of a new generation of renewable resources, including solar, wind, hydroelectric, geothermal, biofuels, tidal, and many more. And we'll take a closer look at each of these types in other videos. Now, the first thing we need to look at is what all of this energy is actually used for. Here in the UK, most of our energy goes on either transport or domestic uses. Transport refers to things like cars, trains, planes, and ships, to name just a few, and primarily relies on petrol and diesel in the case of road vehicles, and kerosene for planes, which are all created from oil and are thus fossil fuels. Traditionally, trains were powered by coal, which helped drive the Industrial Revolution after coal was found in Britain. But now, most trains are powered by electricity. More recently, there's been an increase in the use of biofuels, which are created from renewable sources like plants, and also an increase in the use of electric cars. Domestic uses, on the other hand, refers to household things like cooking and heating. For heating, our main source of energy is natural gas, which is burned to heat water. We then pump this hot water into our radiators, and the thermal energy is transferred to the air in our rooms to keep us warm. Another non-renewable source of heat is coal, which can be burned in fireplaces. There are though some rarer renewable sources of heating as well. Solar water heaters work by using the sun's energy to heat water, which can then be pumped through the radiators in our houses, while biofuels can be burned for heat in a similar manner to coal. Now, the last thing that we want to mention is that electricity by itself isn't renewable or non-renewable. It all depends on how it's made. This pie chart here shows the main sources of electricity in the UK. As you can see, almost 60% is from fossil fuels, and non-renewables together make up nearly 80%. So the vast majority of our electricity is from non-renewable resources. Anyway, that's all for today. So if you enjoyed it, then please give us a like and a comment.
तो जैसा कि आपने देखा कि इंट्रोडक्शन टू एनर्जी सोर्सेज पे आपने देखा वर्ल्ड वाइड जो है किस तरीके से रिन्यूएबल एनर्जी जो हम वर्किंग कर रहे हैं. Okay, we have another video about the sources of energy regarding work energy. or about science. We have to learn. Watch this video.
Sources of energy. There are various sources of energy. They are the following. The sun. The sun is the primary source of energy. Most other forms of energy can be traced back to the sun. The sun directly provides us energy in the form of sunlight. This solar energy is used to produce electricity in a solar cell and heat in a solar cooker or solar water heater. Fossil fuels. Any substance which on burning produces a lot of heat is called a fuel. Wood, coal, kerosene are some examples of fuels. For household purposes, energy is obtained by burning fuels such as kerosene, oil, coal, wood, and LPG. Petrol and diesel are used in cars, scooters, tractors, trucks, diesel train engines, aeroplanes, motors, and other vehicles as fuels to produce energy. Coal is also used to generate electricity in thermal power stations. Water. The energy of running water is used to generate electricity in tidal power stations. The Bhakra Nangal Dam is one of the most important tidal power stations of our country. The energy of running water is also used to run water mills or to transport timber from one place to another in our country. Wind energy. Wind energy is used to run windmills. These windmills in turn are used to generate electricity and hence to pump water. Tidal waves. For generating hydroelectric power, the energy from the sea waves are used. India has good potential to build tidal power stations in Gujarat and West Bengal. Biomass. Garbage, industrial waste, crop residue, sewage, wood bushes, cow dung and other waste material form biomass. Biomass is decomposed in the absence of oxygen to produce methane gas, which can be used as a fuel, and the residue can be utilized as manure for plants. Gobar gas plants are becoming popular in our villages. Atomic energy. Substances like uranium and plutonium are used to generate electricity in our atomic power stations. Renewable and non-renewable sources of energy. Renewable sources of energy are those that can be used again and again and will never run out. Sun, wind, flowing water, and biomass are renewable sources of energy. They are freely available and they do not pollute the environment. Non-renewable sources of energy are those which once used up cannot be replaced. Fuels such as coal, petrol, diesel, kerosene, and natural gas are examples of non-renewable sources of energy.
Okay, in this way, you learn more better about sources of energy, renewable and non-renewable energy sources. Okay, we have to continue the alternative renewable energy policies 2011 We have alternative is a medium-term policy. The Renewable Energy Policy 2006 was updated to Alternative and Renewable Energy Policy 2011. This policy is currently in force and builds upon the short-term policy by resolving policy conflicts and addressing stakeholder concerns, developing the concept and that our projects are actually cost the nation less and thus deserve and require better rate of return than fossil fuel. Developing the policy of non-electric power and a policy of biofuel, expanding incentives for alternative energies such as the Alternative Energy Development Fund, partial resource risk coverage, thrift on the basis of a premium rate of return for developer, a mandatory grid connection, mandatory purchase requirements, small business programs for all less than 10 megawatt, Asian Development Bank, a loan guarantee facility, credit market facility, and 100% carbon credit to independent power producers. So this is alternate policy. The policy for development and renewable energy for power generation employing small hydro, wind, solar technology for short-term policy. This was the first policy implemented by government of Pakistan that firmly supported renewables in the national energy mix. It also provided a policy framework for upscaling renewables. It was developed as a short-term policy with a view to develop a long-term policy. It is tentatively valid until 2018. The goal of this policy was to provide 10% of the Pakistan energy supply mixed by renewable technologies by 2015, focusing on the following technologies: some small hydro power plants of 50 megawatt or less capacity, small photovoltaic and thermal energy for power generation, and wind power generation. Okay, we have other technologies such as those based on municipal solid-based and landfill methane recovery, anaerobic and pyrolytic biomass gasification, co-firing and co-generation utilization, agriculture crops, residue biofuels, web, tidal, geothermal energy, and fuel cell were not yet dealt with this in this policy. It did, however, mention the goal of universal access to electricity. Features of this policy: it invites investment from private sector for independent power projects or IPP as for sale of power to the grid only. Captive cum grid spillover power projects, for example, for self-use and self-utility. Competitive power project, for example, for self or dedicated use, and isolated grid power projects, small standalone, except for IPPs. The other projects don't, require any LOI and LOS or IA-backed assessment from the government. Electricity purchased from qualifying renewable energy-based generation projects is mandatory. Net metering and bidding. De-license and deregulates small-scale power production from renewable sources up to 5 megawatts for hydro and 1 megawatt for net metered scale. Cells. Okay, simplified and transparent principles of determination facilitates projects to obtain carbon credits for avoid greenhouse gas emissions. And in order to fulfill the objective of the policy, one, energy security, 712, economic benefits, social equity, environmental protection, government of Pakistan's strategy included trade. Increase the development of renewable energy technology in Pakistan today already provides renewable energy provides higher target proportion of the national energy supply mix. For example, a minimum of 9,000 megawatt by 2030 as part of the medium-term development framework, and helps ensure universal access to electricity in all regions of the country. Provide additional power supplies to help meet increasing national demand. Introduce investment friendly incentives and facilitate renewable energy market to attract private sector interest in renewable energy projects. Help nurture the nascent industry and gradually lower renewable energy costs and prices through competition in an increasingly deregulated power sectors. DVs measure to support the private sector in mobilizing, financing, and enabling power, public sector investment, and promotional, demonstrative, and trend-setting renewable energy projects. Optimize impact of renewable energy deployment in underdeveloped areas by integrating energy solutions with provision of other social infrastructure, for example, educational and medical facilities. Clean water supply, sanitation, roads, and telecommunications, so as to promote greater social welfare, productive trade, and economic well-being among deprived communities. Help in broad institutional, technical, and operational capacity, facilitate the establishment of the domestic RET manufacturing base in the country that can help lower cost, improve service, create employment, and enhance local technical skills. So we have this data regarding Pakistan and right now the current situation. ओके इसके साथ साथ जैसा कि आपने देखा कि सोलर विंड कोल पावर प्लांट्स एनर्जी सेक्टर इन पाकिस्तान, तो उसके लिए शॉर्ट वीडियो व्हिच विल हेल्प यू फॉर बेटर अंडरस्टैंडिंग. प्लीज वॉच दिस वीडियो.
वालेकुम. हमारे अक्सर सब्सक्राइबर्स जो हमारे बहुत करीबी हैं, बहुत प्यारे हैं, वैसे तो सभी प्यारे हैं, टाल मटोल होती रही, लेकिन अब इन पे सही तरह वो खुलकर सामने आने लगा है. अब वो खुल इस पर काम और तेजी से शुरू कर. अभी तक आपने हमारा चैनल सच टीवी उर्दू, आपको बताते हैं कि कौन सा प्रोजेक्ट कितनी बिजली वक्त पर मिलती रहे. तो अब हम आपको बताते हैं कि कौन सा प्रोजेक्ट कितनी बिजली बनाकर पाकिस्तान को दे रहा है. ये एनर्जी प्रोजेक्ट्स सीपैक का हिस्सा थे. पाकिस्तान चाइना इकोनॉमिक कॉरिडोर के जितने भी एनर्जी प्रोजेक्ट्स थे, इनमें से बहुत सारे कंप्लीट हो चुके हैं और बहुत सारे ऑन गोइंग हैं. जो प्रोजेक्ट्स कंप्लीट हो चुके हैं ये 9 प्रोजेक्ट्स बनते हैं और इनसे 5320 मेगावाट की इलेक्ट्रिसिटी प्रोड्यूस हो रही है. और इन 9 प्रोजेक्ट्स पे जो खर्चा आया था वो है 7.9 अरब अमेरिकी डॉलर का, और इससे तकरीबन 5000 पाकिस्तानियों को नौकरियां मिली हैं. यानी 9 प्रोजेक्ट्स हैं जो कंप्लीट हो चुके हैं, इन पे खर्चा आया है 7.9 अरब डॉलर का. 5320 मेगावाट एनर्जी ये जनरेट कर रहे हैं और इन 9 प्रोजेक्ट्स में 5000 पाकिस्तानी काम कर रहे हैं. अब आते हैं उन प्रोजेक्ट्स पे जिन पे अभी काम हो रहा है, वो कंप्लीट नहीं हुए. वो हैं 8 प्रोजेक्ट्स और इनसे जो बिजली जनरेट होगी वो है 4470 मेगावाट. इन पे इन्वेस्टमेंट होगी 9.55 अरब डॉलर्स की और इनसे 15,227 पाकिस्तानियों को नौकरियां मिली हैं. अगर हम इन्वेस्टमेंट के लिहाज से देखें तो जो प्रोजेक्ट्स कंप्लीट हो चुके हैं उन पे कम इन्वेस्टमेंट आई है, बिजली ज्यादा प्रोड्यूस कर रहे हैं, और जो कंप्लीट होने हैं उन पे इन्वेस्टमेंट ज्यादा आनी है और बिजली उससे कम प्रोड्यूस होगी. लेकिन अगर नौकरियों के लिहाज से देखा जाए तो इसमें ज्यादा पाकिस्तानियों को नौकरी मिली है. अब हम आपको डिटेल्स देते हैं उन प्रोजेक्ट्स की जो कि कंप्लीट हो चुके हैं. उनमें सबसे पहला है साहिवाल कोल पावर प्लांट. ये पंजाब में है और ये 1320 मेगावाट इलेक्ट्रिसिटी जनरेट कर रहा है. इनमें दूसरा प्रोजेक्ट जो है वो सिंध में है, इसका नाम है पोर्ट कासिम कोल पावर प्लांट. ये भी 1320 मेगावाट की बिजली प्रोड्यूस कर रहा है और इसमें भी कोयले से बिजली बन रही है. इनमें जो तीसरा प्रोजेक्ट है वो है हब कोल पावर प्लांट. ये बलूचिस्तान में है, यहाँ भी कोयले से बिजली बन रही है और यहाँ भी 1320 मेगावाट की इलेक्ट्रिसिटी जनरेट हो रही है. इसमें चौथा प्रोजेक्ट है थर कोल पावर प्लांट. ये भी सिंध में है, यहाँ भी कोयले से बिजली बन रही है और यहाँ 660 मेगावाट इलेक्ट्रिसिटी जनरेट हो रही है. लेकिन ये एक बहुत बड़ा प्रोजेक्ट है, इस पे हमने एक अलहदा से वीडियो भी बनाई है. यहाँ इतना कोयला है कि पाकिस्तान अपनी 500 साल की बिजली की और तेल की तमाम जरूरतें खुद भी पूरी कर सकता है और दुनिया को भी बेच सकता है. अगर आपको इसकी मजीद डिटेल्स चाहिए तो कमेंट्स में आप लिखें, हम इस पे एक नई अपडेट्स के साथ एक नई लेटेस्ट वीडियो बना के आपको बताएंगे. इसके बाद जो 5वां है वो है कायदे आजम सोलर पावर प्लांट. इसमें सूरज की रोशनी से बिजली बन रही है. इंतहाई अहम डेवलपमेंट है, एक बहुत बड़ी डेवलपमेंट की तरफ एक बहुत बड़ा कदम है. पाकिस्तान में आप लोग जानते हैं कि सर्दियों में भी रोज धूप निकलती है, तो धूप को हम एनर्जी के लिए इस्तेमाल करना शुरू कर चुके हैं. घरों में तो पहले ही इसका इस्तेमाल शुरू हो चुका है, लेकिन पावर सेक्टर में इसको पहली दफा यूज किया गया है और इसकी लोकेशन है भावलपुर, पंजाब में। अब जो छठा हम आपको बता रहे हैं इसका नाम है हाइड्रो चाइना दाऊद विंड पावर प्लांट। ये भी सिंध में है और ये 49.5 मेगावाट की इलेक्ट्रिसिटी जनरेट कर रहा है। लेकिन ये भी एक बहुत बड़ी डेवलपमेंट है, हवा से बिजली बनाना। ये बड़े बड़े तरक्की याफ्ता ममालिक में ये काम हो रहा है, हवा से बिजली बनती है। पाकिस्तान में भी ये काम शुरू हो चुका है ऑफिशियली। तरक्की की तरफ एक बहुत बड़ा कदम है। ऐसी ऐसी जगह हैं पाकिस्तान में जहां 24 घंटे हवाएं चल रही हैं और हम अब इसको कैश कर सकते हैं। सूरज को कैश कर सकते हैं, हवा को कैश कर सकते हैं, अपनी एनर्जी की जरूरियात पूरी कर सकते हैं। हवा से बिजली बनाने वाला जो एक और प्रोजेक्ट है, जो 7वां प्रोजेक्ट है, उसका नाम है UEP विंड फार्म झीमपीर ठट्ठा। ये भी सिंध में है और यहाँ पर 99 मेगावाट बिजली प्रोड्यूस हो रही है। और हवा से ही बिजली बनाने वाला एक तीसरा विंड प्लांट है, उसका नाम है सच्चर विंड फार्म झिमपीर। यहाँ से 49.5 मेगावाट की बिजली जनरेट हो रही है। इसमें जो हमारे पास 9वें नंबर पर है वो है 100 मेगावाट का, इसका नाम है 3 गॉर्जेस सेकंड एंड थर्ड विंड पावर प्लांट। इससे भी 100 मेगावाट इलेक्ट्रिसिटी जनरेट हो रही है और ये भी हवा से बिजली बना रहा है। तो नाजरीन, इस सब में खुशी की बात यह है कि हम अब एक टिपिकल तरीके से हट चुके हैं। डैम्स बनाने चाहिए, मुल्क की ज़रूरत है पानी की कमी पूरा करने के लिए, सैलाबों की रोकथाम के लिए, हर चीज़ के लिए डैम की ज़रूरत बिल्कुल है। लेकिन हम लकीर के फ़कीर ना बने, सिर्फ डैम पर ही डिपेंडेंट ना रहें। सारी दुनिया में जो काम हो रहे हैं, जिस रफ्तार से दुनिया भाग रही है, हम इसमें इतने पीछे क्यों थे? अभी हम दुनिया के साथ चल रहे हैं, भले छोटे लेवल पर, क्योंकि अभी हमने स्टार्ट किया है। लेकिन आप ये देखें कि मैंने आपको टोटल 9 प्लांट्स बताए हैं जो बिजली जनरेट कर रहे हैं, जो हमने ये चाइना पाकिस्तान इकोनॉमिक कॉरिडोर के जरिए ये प्रोजेक्ट शुरू किए थे और जो कंप्लीट हो चुके हैं और बिजली जनरेट कर रहे हैं। इसमें खास बात यह है कि इन 9 में से आप देखें तो पहले 4 पावर प्लांट जो हैं वो कोयले से बिजली बना रहे हैं, जो कि एक बहुत बड़ी डेवलपमेंट है। पाकिस्तान में इतना कोयला है। हम बचपन से सुन रहे थे कि इस पर काम होगा और हमारी तकदीर बदल जाएगी, लेकिन नहीं हो रहा था। अब शुरू हो चुका है और इसमें इंतहाई अहम है थर्मल पावर प्लांट।
ओके, जिस तरह से आप देख रहे हैं कि बड़ा इंटरेस्टिंग जो डॉक्यूमेंट्री थी अबाउट पाकिस्तान की, और बड़ी इंफॉर्मेटिव नॉलेज अबाउट पावर प्लांट्स कौन कौन से रनिंग में चल रहे हैं, कौन कौन से नहीं चल रहे हैं ऑपरेटिंग में। सो कंटिन्यू करते हैं और उसके साथ देखते हैं। लेट्स कंटिन्यू अबाउट कोल पावर प्लांट्स।
दोस्तों, ये यकीनन पाकिस्तान की तकदीर बदल सकता है। अगर इससे हम पेट्रोल बनाना शुरू कर दें इस कोयले से, तो सऊदी अरब और ईरान के मजमूई तेल के ज़खायर से ज्यादा पेट्रोल बनता है खाली यहाँ पर। फिर हमने आपको एक सोलर पावर प्लांट बताया, सूरज से बिजली बनाने का। पाकिस्तान में सर्दियों में भी सूरज निकलता है। आप यूरोप में जाके देखें, वो सूरज को तरसते हैं, लेकिन वो सूरज से बिजली बना रहे हैं। यहाँ तो हम अभी तक सो रहे थे। कर्जे लो, बड़े बड़े प्रोजेक्ट्स बनाओ, आधे पैसे जेब में डालो, आधे पैसे लगा दो, वापस किसने उतारने हैं? अवाम ने। और बनाना क्या है? पुलें बनानी है, नालियां बनानी है, गलियां बनानी है, और ऐसे बनानी है कि थोड़े अरसे बाद ये फिर टूट जाएं और फिर इन पे हम पैसे लगा सकें और करप्शन कर सकें। ऐसे काम जिनमें नस्लों का भला हो वो तो कभी हुए ही नहीं थे यहाँ पे। अब हम आपको बताते हैं पाकिस्तान के जो फ्यूचर प्लान्स हैं, वो ये हैं कि पाकिस्तान में 2030 तक जो बिजली पैदा हो वो 60% पानी के जरिए पैदा हो और बाकी की बिजली इन रिन्यूएबल एनर्जी सोर्सेज के जरिए पैदा होती रहे, जो सोर्सेज हमने भी आपको बताई इनके जरिए। लेकिन पाकिस्तान का प्लान यह है कि 2030 से ऑनवर्ड तक हम इस काबिल हो चुके हों कि हम इन मेथड्स के जरिए अपनी 80% बिजली बनाएं। और ये बहुत अच्छी डेवलपमेंट है। अगर ये चीजें हो जाती हैं तो पाकिस्तान का बहुत बड़ा ज़र मुबादला बचेगा। एनर्जी पाकिस्तान का हमेशा से बहुत बड़ा मसला रहा है और पिछले कई सालों में आपने देखा कि लोड शेडिंग के इतने मसाइल थे कि हमारी सारी इंडस्ट्री भी हमारे हाथ से निकल गई। पाकिस्तान टेक्सटाइल के सेक्टर में दुनिया में एक नाम रखता था। ہم نے خود دیکھا جرمنی کا ایک بہت بڑا برانڈ ہے C&A, وہاں سے لوگ اکثر کپڑوں کی شاپنگ کرتے ہیں. 2004 میں جب میں وہاں پر گیا تھا تو وہاں پہ 70% جینز جو تھی وہ میڈ ان پاکستان ہوتی تھی. آج آپ جا کر دیکھیں سب میڈ ان بنگلہ دیش اور میڈ ان انڈیا ہے. ساری انڈسٹری فیصل آباد سے چلی گئی بنگلہ دیش, وہی پاکستانی ہے. اب بنگلہ دیش کو فائدہ ہو رہا ہے, اور اس کی سب سے بڑی وجہ کیا تھی؟ انرجی. یہ چیزیں دیکھ کر دل دکھتا تھا. LNG سے بجلی بننا شروع ہوئی تو وہ کتنی مہنگی پڑی ہمیں, کیونکہ LNG ہمیں باہر سے منگوانی پڑتی ہے, پیسہ ہمیں باہر کے ممالک کو دینا پڑتا ہے, زر مبادلہ باہر جاتا ہے. ہم وہ سورسز کیوں نہیں یوز کرتے جو ہمارے پاس ہیں, اللہ کی طرف سے ہیں؟ ہوا ہے, سورج ہے, کوئلہ ہے, یہ سب اللہ کی طرف سے ہے. تو ہمیں دوسرے ممالک سے سورسز خرید کر بجلی بنانے کی کیوں ضرورت پڑتی ہے؟ کیونکہ کمیشنیں آ سکیں جیبوں میں. اور جن ممالک کے ساتھ مل کر ہم یہ کام کرتے ہیں وہ اپنے ملکوں کا فائدہ سوچتے ہیں, اور یہاں سیاستدان اپنی جیبوں کا فائدہ سوچتے ہیں. اس قوم کا کیا ہے؟ یہ تو بے وقوف ہے, یہ تو ہمارے لیے پھر لڑے گی, پھر مرے گی. اگر کوئی سچا لیڈر ان کے لیے کھڑا ہو گیا تو ہم اتنا پروپیگنڈا کریں گے, ایسی گیمیں کریں گے کہ وہ حکومت بھی نہ چلا سکے, ایسے پروپیگنڈے کریں گے کہ عوام ہی اس کے خلاف ہو جائے. اگر وہ عمران خان کی طرح کا فائٹر نہ ہوتا تو اب تک بھاگ چکا ہوتا. ناظرین, آپ کا اس سب کے بارے میں کیا کہنا ہے؟ کمنٹس میں اپنی رائے کا اظہار ضرور کریں, اور اگر آپ ہمارے چینل پر نئے ہیں تو ابھی سچ ٹی وی اردو کو
نوائز ایکچولی بہت اچھی طرح سے اس نے ڈاکومنٹری کو پریزنٹ کیا, اور میں نے چاہا آپ کے ساتھ شیئر کروں دس ویڈیو. اوکے, اس کے ساتھ ساتھ یہ لیکچر جو ویک 2 ہے اس کے اباؤٹ رینیویبل انرجیز اینڈ فاسل فیول کے بارے میں پاکستان نے آپ کو ڈاکیومنٹری دکھائی, تو اس کے کنٹینیو میں کرنا چاہوں کہ ان دا لاسٹ اباؤٹ دا پاکستان گیٹ سیریس اباؤٹ رینیویبل انرجی. سو پلیز واچ دس ویڈیو فار یور بیٹر انڈرسٹینڈنگ.
دسمبر 2014 کو اس کی ہماری کمرشل آپریشن شروع ہو گیا تھا. سنس دین وی آر رننگ دس ماشاء اللہ سکسیزفلی. وی آر ناٹ پروڈیوسنگ اینی کاربن ڈائی آکسائڈ اینڈ رادر وی آر کنزرونگ دی انوائرمنٹ. وی آر پرووائڈنگ دی گرین انرجی.
Out of the 300 megawatts of operational power at the moment, about 156 megawatts of power have been financed by ADB. This includes the both Fuji Wind 1 and 2, and also the Zulu Power.
World class, state of the art, top of the range equipment used here, and they are quite efficient. Their project life is more, and we hope that apart from returning its initial investment, this will give a good profit to the nation as well.
We started out with a tariff range of around 14.5 cents. They came down to about 12.5 cents in the second round, and in the third round they will be around 10.5. So hopefully after that there will be sub 10 cents level, the projects that come out by 2020. This is how the cost of production basically is going down, and at the end of the day it is helping the government of Pakistan bring down the cost of generation of power.
پہلے یہاں پہ تو کچھ نہیں ہوتا تھا, پانی ہوتا تھا, یہاں سمندر تھا, تو جو مچھیرے آتے تھے یا کچھ وغیرہ ان کو بھی تکلیفیں ہوتی تھی کہ رستہ نہیں تھا اندر آنے کے لیے, باہر ہی کھڑے ہوتے تھے. اور اس کمپنی کی وجہ سے وہ کوسٹل ہائی وے بھی بن گیا ہے جو کیٹی بندر تک جا رہا ہے ابھی. اس سے ہمیں بہت فائدہ ہوا ہے, اور ہمیں ادھر روزگار بھی مل گیا ہے. یہ جو پروجیکٹ کھلا ہے ابھی,
ابھی اس روڈ سے ہمیں بہت سارا فائدہ ہوا ہے, بہت سارا. جہاں پہ ہمیں 5 سے 10 گھنٹے 6 گھنٹے 7 گھنٹے لگتے تھے, ابھی ہم 2 گھنٹے میں وہاں پہنچ جاتے ہیں. پہلے مال مر جاتا تھا, راستہ کچا تھا, پانی کی سمندر کی چڑھتی تھی, زمین گیلی ہو جاتی تھی, گاڑیاں پھنس جاتی تھی, پھر ٹریکٹر وغیرہ سے نکالتے تھے. ابھی وہ سسٹم نہیں ہے. لاس ہوتا تھا, ابھی اتنا لاس نہیں ہے. ابھی جو ہے اتنا ہمارے جو محنت کر رہے ہیں رات دن, بچوں کا روزی روزگار ہمارا چل رہا ہے.
بجلی پہلے بہت زیادہ جاتی تھی جس سے ہمیں نقصان ہوتا تھا, ہماری انکم میں فرق پڑتا تھا, کسٹمر ناراض ہو کے چلے جاتے تھے. اب جو ہے بجلی بہت کم جا رہی ہے جس سے ہمارے بزنس میں فرق پڑا ہے, اور کمائی میں بہت زیادہ جو ہے نا وہ ہو رہا ہے, اور کسٹمر خوش ہو کے جا رہے ہیں.
actually Pakistan situation moving towards renewable energy sources और आपने विंड टर्बाइन के हवाले से वीडियो देखी आपने तो ये हमारे लिए रहा अपना सेकंड लेक्चर week 2 so we learn a lot of things regarding week 2 about let me show you actually today we learn about technology for conversion of heat electricity and transport and biomass and conventional and unconventional sources and renewable and non-renewable sources of the Pakistan. So that's all. If you have any problem, please contact me. Feel free to